In this video, we're asked to prove AD is congruent to CD, those segments. Given the information that segment DB is perpendicular to segment AC and that segment BD bisects angle ADC. Given out already. I'm going to go through in vocabulary. First part I see is perpendicular, so I'm going to look at the segments that are perpendicular. That's DB and AC. And I recognize, if those are perpendicular, I'm going to get right angles. So identify the angle DBA and angle DBC are right angles. Okay, that's definition of perpendicular lines. Okay, the definition of perpendicular lines says two segments that form right angles. So that's what gives me these right angles. Now I know, and I'm going to put these hash marks in here right away, because I know that if I have multiple angles that are right angles, I always want to say that those angles themselves are congruent to one another. Okay, every right angle is equal to every other right angle, or congruent. All right angles are congruent. Looking at this picture, it also tells me, going through my vocabulary, that BD bisects angle ADC. So bisects is a key word. That word means cuts into two equal parts. We're bisecting an angle, so we're going to cut an angle into two equal parts. What angle? Well, it's angle ADC. So it's this angle here that we're bisecting. So the two new angles that are created are this one here and that one there. So I want to identify those as angle ADB congruent to angle CDB. And what gave those angles to me? How did I know those angles to be congruent? Because the definition of an angle bisector states that it's a ray or a segment or a line that takes an angle and it divides it into two congruent angles. So steps 2, 3, and 4 all come from vocabulary words. We'll go to step 5, which, we're done with vocabulary words, so now we've got to look at the picture and see what does the picture hide anything for me. And we recognize that that segment right there is in both triangles. So I want to say that that segment's congruent to itself. So DB is congruent to DB, and that's the reflexive property. So now with my triangles, I know the triangle on the left to be congruent with the triangle on the right because I have angle, side, angle in both of them. So I'll say triangle ABD is congruent to triangle CBD at angle, side, angle. And now that I know that, it's not what we wanted to prove. We want to go back up. What did they want us to prove? AD congruent to CD. Well, A and D are the first two letters. C and D, the first and last letters. C and D are the first and last letters. So they're corresponding parts. So I'll say segment AD is congruent to segment CD, and my reason is CP, CTC, corresponding parts of congruent triangles are congruent. And we're done.